I will be doing my classification talk. And so thought I'd start off with a little bit about my past. And so I was born and raised in California, and I moved to the Valley in 2008, where I finished middle school and high school. And so in 2013, I actually graduated from CHS in the top 10 of my class. And then later that year, I started studying chemistry at LCSC. And earlier this year, I actually got to compete with the first team to represent LC at the Idaho Entrepreneurship Challenge at Boise State. So that was pretty cool. And now I'm actually going to tell you a little bit about some of the instruments I've learned how to use. And so that is the Ftir, and it just measures the absorbance of IR radiation in a sample. And here I'm just showing some standard air samples that were sent to our lab by UC Irvine, and we just use that to check the accuracy of our own instruments just to see if they're right. And the Uvb Spectrometer just measures the concentration of trace metals in a solution. And the next one is a Uvb Spectrometer, and this actually just measures the absorbance of light in the UV visible range. And so that's just based on the Beer-Lambert law, which states that absorbance is proportional to concentration. And so this actually leads me to the next instrument, which I'm using in air quality research this semester. And a couple of other students and I just take some samples on a weekly basis at different locations in the Valley. And what we do is we just take one of these air pumps similar to that, and we just hook it up to a ring stand so that the tubing is straight, and we take a sorbent tube and we just stick it on the end of the pump and just pump air through it for about like 10 minutes. And then when we get back to the lab, we put it into that instrument, the TDGCMS. And here I'm just showing a log of all the samples that we've ran and done Q edits on, and pretty much what the instrument does is it's going to just analyze the air sample and give us a fingerprint of the sample so we can see exactly what's in the air at that time. And so I don't know if I've lost anyone, but if you have any questions, I'd be happy to answer them right now if you have any. If not, I can just move on to the next slide. Other than being a chemist, I actually dabble with a little bit of social media marketing. And so this logo that you're about to see is actually one that I made for myself, and I use that on all my social media platforms. And that includes Facebook, YouTube, Instagram, Fuse, and my blog. And I use those platforms to promote some companies that I'm affiliated with. And so on my blog, I actually feature some of my travel experiences, and one of my favorite ones that I featured is Ice Lake. And so this is in the Wallowas, and it's actually a 13-mile hike, and it took Pete and I about like 4.5 hours just to get to the campsite, which was up by the lake. So yeah, it's definitely a hike. Takes longer than a day, but if you want to read more about that, you can go to my blog, and there's a full post on that with a lot of really pretty pictures. So if you're into that stuff, definitely can check that out. And then I wanted to do a demonstration, but this one that I specifically wanted to do isn't the safest to do outside of a lab. But so I thought I'd just share a video of what I did in my class. And so we actually prepared a contact explosive, which is nitrogen triiodide. And yeah, it's probably not the safest to do outside of a hood. But pretty much nitrogen triiodide is just really unstable and really reactive. And so how we made that was we combined some iodine crystals with some concentrated ammonia, and we just let that dry on a piece of filter paper. But because of the difference in size between the nitrogen and iodine atoms, the bond between them is really weak. And so when it dries, the iodine atoms are actually getting pushed a lot closer to the nitrogen, so there's a lot of repulsion between them, and that's why it's really unstable, and it will explode. Not necessarily like that, but yeah, it's just a really unstable explosive, but it's a good way to learn how to work with it. in my inorganic chemistry class is what I did that in. And then now that leads me to the future. And so if you don't know, I'm actually finishing my last semester of school, and so I will be graduating in May. And Pete and I are actually planning on just staying in the Valley because we see that there is a need to improve competitiveness in science and technology. And so there's actually a stigma in the Valley that to be successful, you have to either, work at a factory or you kind of just have to leave. But what we want to do is actually eventually build an after-school program based on STEAM, which is just science, technology, engineering, art, and math. And so, yeah, by bringing this program into the Valley, we actually just want to dissolve that stigma by just showing them that there's more opportunities than just working at a factory or leaving or working at Walmart, whatever it is. But yeah, and so that is actually why I wanted to join Rotaries, because I like helping people and I just want to make a difference in my community. So yeah, thank you for listening. Yes.
Talk a little bit about your family, brothers, sisters, how long you've lived here.
So yeah, I moved here when I was 12. So actually on Friday I'll be 22. So you can do the math. But I have 2 brothers, and then I have 2 stepbrothers. There's 6 of us total. It's kind of confusing because my mom got remarried, but yeah, I have 2 brothers, 2 stepbrothers, and then a half sister who's 8. So yeah, she's going to Lewiston right now in Webster. But